Continuing our review with linear equations, we need to focus on the equations of horizontal and vertical lines for just a minute. Horizontal lines are always going to be of one certain form. They're always going to take the form y equals c, or y equals a number. So some examples would be y equals 2, y equals -3, y equals pi, any number. If you think about it, a horizontal line is one that has a slope of 0, and normally we have something of the form y equals mx plus b. So if our slope is 0, then you just end up with y equals b. So that's why it's just y equals a number when it comes to horizontal lines. Now vertical lines are going to be of the form x equals a number, because they're just the opposite. Horizontal lines will be y equals a number, vertical lines will be x equals a number. So this could be x equals 5, x equals -2, x equals 125, any number. And this will be a vertical line that passes through that x value on the x-axis. So that's horizontal and vertical lines. Okay, the other thing we need to cover is how to write an equation of a line if you're given a point and another line that you're parallel to. Okay, the two things you must have for the equation of a line are a slope and a point. Now here they give you the point very explicitly, it's obvious. Now they give you information to help you find the slope, because if you remember, parallel, if two lines are parallel, then they have the same slope. So if we can figure out the slope of this line over here, we can figure out the slope of our line. If you remember, y equals mx plus b, the m, or the number in front of x, is your slope. So the slope is 2. So our point is -3, 2, and our slope is 2. So if we use the point slope form, we get y minus y is 2 equals m, that's also 2, slope, x minus -3, so that's really +3, we get that. Okay, then we'll distribute this 2 right here and get 2x plus 6, and then add 2 to both sides and get y equals 2x plus 8. So if you notice, these two both have y equals 2x in them, and that's because they have the same slope. Their y-intercepts, however, are different because they're at different spots. So these, just to give you a rough idea, would look something like this, would be y equals 2x plus 1, and then y equals 2x plus 8 would hit somewhere higher up. Okay, this last example is similar to what we just did, just a little extra work we have to do. It says write the equation of the line that passes through 7, 1 and is parallel to 2x minus 6y equals 12. So same idea, we need a point and a slope. We have the point, it's 7, 1. We need to find the slope. Okay, well we know parallel means that it has the same slope as this equation, but it's not immediately clear what the slope of that equation is because it's not in slope-intercept form. So that's what we need to do, is put it in slope-intercept form. So if you subtract 2x from both sides and then divide both sides by -6, -2 divided by -6 is positive 1/3. 12 divided by -6 is -2. So our slope is 1/3. So again, we'll use the point slope form. Our y value is 1. Our slope is 1/3. Our x value is 7. So then I distribute the 1/3 and I add 1 to both sides. Since 1 is 3/3, you add 3/3 to -7/3 and you get -4/3. And that is our answer. Okay, I believe that's all we have. Page 189 in our book has some problems like this. If you want to look at how to graph horizontal and vertical lines, or how to find equation of the lines when you're given one point in a parallel line.